Hello, everyone, and welcome to this Geospatial World presentation on empowering surveyors around the globe. So my name is Luke Johnson, and I am the Technical Product Manager for Survey Field Software here at Trimble. And my main role is working with the Trimble Access field software that is used by surveyors around the globe to survey efficiently and quickly. So let's get started. So this is my presentation here. And we've got a lot to cover today, so I'll just get straight into it. So Trimble Access is a field software built for surveyors by surveyors. Our team here, I'm here in Christchurch, New Zealand, is made up of a lot of surveyors working hand in hand with software developers. And together we put together a really good application for surveyors to use. The Trimble Access application has evolved a lot over the years. It started out in 1997 with Survey Controller running on the TSC1. You can see there's no color. We then moved to the Survey Controller TSC2, showing, we upgraded it to involve color. In 2011, we moved to the TSC3 platform, and we had a whole new redesign. That was when Trimble Access began. So here we have Trimble Access. You can see over the course of those years, not much has changed. We still have those key functions. And then recently in 2018, when we moved more to a Windows and Android platform, we redesigned the app to have more of a sort of mobile app feel. But if you can see in that main menu, most of those key core functions are still there. So although it's changed a bit over the years, all that functionality has remained. So I really like this slide just to show the evolution of how things have changed over history. So here you can see some of the early data collectors or survey controllers we used, all the way through to what we are running now. So we've got the TSC5, the TSC7, as well as some other platforms. So Trimble Access is, again, designed by surveyors for surveys, and that's what really makes it a trusted field software. So it has great, as you'll see in later slides, a great user interface. It's intuitive, easy to navigate. All the touch gestures are a lot like what you're used to with your phone or your tablet. The map and form layout, we have a split screen. We make use of all that large real estate from sort of modern devices. And with that split screen, we can use the map alongside the form to help give some context to what we're doing. We also have a whole lot of cloud data sync functionality, which makes sending the data from the office to the field and back really simple. So first I'll talk about the split screen. So in Trimble Access now, most of our forms are split screen. So you can see here, once we open a form, we've got the map alongside the form of what we're going to be doing. So these screens are all resizable. You can drag them, make them bigger, make them smaller, depending on what you're doing. And this can be really, really useful, especially on portrait devices. So here you can increase that form if you need to fill in some details, or you can bring the map up bigger if you need to get more context to see what's going on. Having the map selection and the map active also gives you that you can interact with it when you're in a form. So here I'm computing an inverse and I'm actually tapping the points in the map. I don't have to remember the point name. I can directly interact with the map, which makes doing a lot of these COGO functions really easy. To build on that, some of the other COGO functions we have, like this one here, we're computing a point from intersecting two circles. We actually can see those circles. And we can see, if you notice here, there's two different options where that point could be. It could be at the bottom where those two intersect, or it could be at the top. Having this graphical interface really lets us be sure we know which point is being calculated. So the next thing we're going to look at is measure codes. So this is Trimble Access's way of quickly and efficiently collecting feature data about points. So the measure codes form is here. It's a grid-like function. You can drag it again, bigger and smaller. And each one of those buttons you can press to measure and code a point at the same time. So the split screen really makes this coding efficient because it means that you can see what you're doing as you're doing it. So if you're measuring a line, you can see that see that line being created, and you can see if you make mistakes. You can edit these groups of codes, so you can have multiple groups of codes. Each page can be a different thing. So we can tap the edit button and we can create different groups of code. So here I've got a group full of earth drainage codes. If I wanted to, I could change that group to something else, and that would be where for example, I could be going to my road structures group. And again, these groups can have different numbers of codes and different layouts, depending on what you need. You can also use templates. So templates are what they do is they allow you to easily pick up cross sections along a road, for example, or along a footpath. So these will change the code to the next one in the group um, for you. So all you have to do is press enter, enter, enter as you're running along the road. So the codes will change in this order that's been shown on the screen, and then they'll go back. So that lets you walk across a road and go down and then zigzag back across without having to think about what code you want next. It automatically switches to the next one for you. We also have a CAD toolbar, which makes coding with control codes really simple. So what this does is it lets you do stuff like arcs and 3-point polygons all in the field without having to go back and compute that stuff in the office. So to enable this toolbar, you go into that menu and turn on the CAD toolbar. And then there's a really easy graphical interface to help you code these arcs. So to code an arc for this back of curb code I've got here, you just tap the start arc button, and then you click your back of curb code. And then you can measure points along that back of curb, and they will be computed as an arc. So that saves you a lot of time in the office from changing a whole lot of points along an arc. You can just do it in the field with the arc code. Next, we're going to just quickly talk about some keypad shortcuts. So it's all great using the keypad, but if it's raining maybe or you're wearing gloves, you can also use the actual physical buttons on the controller to easily initiate measurements. So you can see here, each of these buttons has a number. So if you press the corresponding number on your keypad, then it will initiate that measurement. So you don't even have to touch the screen. Another really nice tip is you can use the alphabet, the letters on your keypad, sorry, to jump between your different groups. So A will take you to the first group, B will take you to the second group. So you can navigate all these forms without even touching the screen. So there's been a few map enhancements too with the newer screens in Trimble Access. And one of the really important ones, is that all the COGO functions are now available directly from the map. What this means is it means if you select things in the map and then tap and hold the screen, you'll be prompted with a menu that gives you everything you could do with that. So here I'm going to select 3 points, tap and hold the screen, and you can see all the options that are available from those 3 points. You could key in a polyline, an arc, create a surface, compute the volume between them. So rather than having to go through the menu and find the relevant COGO function, you can just tap the points on the map and tap and hold. So here I'm just going to key in an arc. It takes us to the key and arc page, and we can create that arc directly from the map. I tapped a line, and now I'm going to create an offset to that line. Easy, and as you can see, everything's shown graphically in the map. We also have a Snap to toolbar. Now, what this allows for is it allows users to really easily select points and lines, well, points on line work. So if you're using a DXF file, you're staking out maybe the end point of a line or the center point of the line, you can use the Snap to toolbar to easily select those points. So to do this, you turn the Snap toolbar on under the 3 dots menu at the bottom there, and that top button selects the midpoint of the line. So I just select that button and tap the line. And as you can see there, we've created a point in the center of that line. So we've also got the end point. So tapping that one in the line will get you to the end point. We have an intersection point. So if you select that one, select two lines, it'll intersect that line, and you can see there it's got the dotted lines to show you where it's going to create that point. This next one here is the tangent point of an arc. So I tap that point and tap the arc, and we can stake out the tangent point as well as the radius point. And the bottom one there is any nearest point. Now from here, I can just directly stake out these points, or if I want to save them for later to stake them out later, I just again go to the tap and hold menu and create points. And I can give those a name or a code or anything like that. The next thing I wanted to show you, which is a lot of our buttons have this little corner notch. So you can see here and here and here, all these buttons have little corner notches. And for any of you currently using Access, I really recommend you trying what I'm going to show you. If you tap and hold those buttons, an extra function will appear. So here I'm going to show you how you can tap and hold the Zoom Extents button to set an area of interest. Now, an area of interest, what you'd do is you'd set that on an area you go to often. And you can return to that area just by a couple of clicks. So now I'll show you, I'll zoom out to another area of the map. But if I want to go back, I can just tap and hold on that button and view area of extents. That's a really useful function. You can also change your zoom extents under that. But every button that has a little corner notch has something extra hidden behind a tap and hold gesture. So I'd recommend any of you currently using Access to have a look at what those tap and hold buttons do. Another thing that I find really useful, just a little hint, but I think it's really useful, is if you ever accidentally pan the map away from where you were, there's a really quick shortcut to get back, and that's just Control Z. That'll take you back to the last map extents. Another really good way, an easy way to sort of personalize the controller to your workflow and make your workflow easier is the favorites and functions. So you can set any form in Trimble Access to be a favorite or a function. And you do this by tapping the little star icon in the corner of the form. So here, I'm going to set the site calibration form to be a function. So I'll tap the star, or no, I've set it to be a favorite, and now I'm setting it to be a function. And so then it brings up the function keys, and from here I can set it to any function key on my controller. So I've just set it to F2. And that means now when I press F2 on the keypad, I will be automatically taken to that form. You can also create groups of favorites and functions for different types of surveys. So this means if I've got a total station survey where I use lots of total station functions, like I turn on the laser a lot or I turn on the video a lot, I can keep that separate and have a different group for GNSS related functions, like jumping to my satellite plot or maybe doing a site calibration. So I'm going to show you how we can create different groups of favorites and functions. So we do that under the main menu and we tap Edit, and we can just tap New Group. So here I'm creating a group of GNSS favorites, and I'm going to set them to be defaults. And I'm also going to create a group of total station favorites. And by setting them as default, they just put the default favorites into that form. So next, another really handy function is to have you automatically choose the favorite group based on what instrument you're connected to. So what I mean here is when you connect to a GNSS receiver, Trimble Access will automatically select the GNSS group of favorites. And then the same thing that happens if you connect to a total station will automatically select the total station favorites. So you can do this by tapping the little 3 dots next to the favorite group and tapping auto switch to GNSS or auto switch to conventional. And you can see there's a little icon next to each of these favorite groups to indicate that this will automatically switch to this group when we connect to a total station. The other thing that's on this form is the function keys. So now the function keys are also mapped to these favorite groups. So that means if I have a group of GNSS favorites, I also have a group of GNSS favorites function keys. So here, if I go to the function key tab, you can see that here. I've got the favorites function keys, I've got the GNSS favorites function keys, and I've got the total station favorite function keys. So what you can do is there's a lot of extra special functions you can assign to these keys that aren't just on forms. So here I'm going to go into my total station favorites, and there's a huge list of different functions you can add. I'm going to set jumping to the map as a function key. So now when I press F1, I'm going to jump to the map, but that'll only happen when I'm in a total state, when I'm connected to a total station. So next we're going to talk a little bit about our total stations and some tips and tricks that can help when using a total station. So with Trimble Access, and when you're surveying with a total station, you often have different targets that you're pointing to. One might be a target for a backsite, so a traverse prism. Another might be a mini prism for when you're doing stakeout. So we've provided an easy way to store profiles of your targets under these forms. So you can drop from the list to see what type of target, and that will automatically fill in the prism constant. It also gives you a nice little visual to show what sort of target it is, and you can give it a display name. So if you have one target that's, I don't know, on the back of a building, you can mark that out clearly so you always know which one to turn to. So yeah, we've got those different lists of total state of prisms in that form. Here is a screenshot of some of the really useful function keys that can be used with a total station. So one of my favorites to set up is the zoom in and zoom out. Now this can work with both the map and the camera. So if you're using a total station with a camera, and you often find yourself tapping the little plus button in the corner and the minus button in the corner, it can sometimes be a whole lot easier to just set that to a function key and click a physical key on your keyboard. Another one that I use a lot is the string plus string minus. So this means when you're feature coding and you're coding lines, every time you want to do a new line that's not joined to the previous line, you have to add a string. So you can set those as function keys as well. Another good function key to assign, especially to something like a TDC 600, which doesn't have a keyboard, is the enter function key. So this will select and click enter every time you press the button. So that's really useful when you don't have a physical enter key on your keypad and you just want to set a function key to do the enter. Video is another good one to jump to. There's lots of other total station relevant things you can add to this form. Traverse adjustments. When you do a traverse, traditionally the practice is to bring that back into the office and then adjust that in a software like TBC. But quite often it's useful to be able to adjust it in the field if you're going to be doing engineering work or something like that and you don't want another trip back to the office. So you can do traverse adjustments directly in Trimble Access. And again, it's really easy to see what's going on with the graphics and the map. So here I'm going to choose the start station that I started at. And then I get a choice of what observation, which way am I wanting to do this traverse. So you can see as I click through, that's the way I've traversed through. And then I get my angular close, my distance close, and I can adjust that traverse. And that means I can go and set up on those points again and set out pegs or bolts from an adjusted coordinate. Another really nice little thing with Trimble Access is we have lots of little shortcuts. There's a video online that I can point to anyone after this presentation to detail them all. But another good one is Control P will take you directly to the target form or the prism form as we call it. That's why it's P. There's lots of other ones in Trimble Access. One of my favorites is Control M to take you back to the map or Control R to take you to review job. But it's worth either looking at the Trimble help file or looking at the online tips and tricks videos just to see how these can streamline your workflows. Next, we'll look at some tips and tricks for using GNSS receivers with Trimble Access. So one function that's reasonably recent in Trimble Access is the satellite subset feature. So typical survey practice says you should go back to a survey mark after half an hour or an hour once the satellite geometry has changed for an independent shot. But recently, with the development and all the GNSS constellations, we're getting, 30 or 40 satellites in a go. So what we've done is we've added in a functionality to split the satellites into two independent groups with different geometry. And that means you can immediately take an independent shot without having to come back later. So I'll show you how this works. We go to the satellites button in the top corner and we click satellite set A. And that will drop half the satellites. What it does is it actually it orders them in azimuth and then goes one to set A, one to set B, one to set A, one to set B. And this provides a really good geometry for both groups. So both groups are completely independent because they have different satellites, but they both have good geometry. So here you'll see we lose initialization and then we regain it. And now we've got half the satellites and we can measure a point. And then we repeat the process to jump to satellite set B. And then again, it's good practice to measure satellite set A, satellite set B, but always an observation with all the satellites is always going to be better. So you can do your independent observations with set A and set B, but it's always recommended to take another observation with just all of the satellites and use that as your final observation on a point, or even better, average all three. So another way you can quickly jump between sets is you can set this as a function key. So if I go into my edit button there and go to function keys, I'll add it to my GNSS function keys. Under other, there is switch satellite group. So by pressing that button, we'll jump between set A, set B, and all. And that can really save you some time rather than going into that other form every time you need to switch satellite groups. So if you're using a receiver with an e-bubble, you can use Control L to easily toggle on and off the e-bubble. I think, do we have an e-bubble in this video? No. The next thing I wanted to show you is the multi-tilt point. Now, this is a way to get a tilted measurement if you're using an instrument that doesn't have an IMU, but it does have to have an e-bubble. So what you've got to do in this case is you go into measure and you change the method to multi-tilt point. So what we're going to have to do here is we're going to have to take 3 observations. So first, we can see me there tilting the instrument in one direction. We have to tilt the instrument in another direction. And then finally, we move it and tilt it in the third direction, all the time keeping the point in the same place. And what's happening is because we have the e-bubble, we know how far the instrument's tilted. So we can draw a circle around the center of where the antenna is. And if we do that 3 times, we can determine a intersection. We can give you the horizontal precision and vertical precision of that intersection and compute that point. Okay, how do I jump to the next slide? There we go. When you're using tilt measurements with an R12i, for example, one of our IMU-enabled receivers, you'll see that it's just the same as measuring a normal point, except you just don't have to level the receiver. And that may sound like it's not much of a feature, but it's actually really, really, it can really, really improve your workflow and improve the speed you do things. Another really useful little function here is because it's got an IMU, it's an IMU enabled receiver, it knows its heading. So you can see that icon there has a little point to it, and that means which way you're facing. So that can be really useful when you're headed towards, can be really useful when you're trying to find a stakeout point or a certain area on the map to go to. you can just turn until the arrow points in the right direction and head in that direction. Next thing I'm going to show you is if you have an IMU enabled receiver, the horizontal tilt offset. So what this does is this is when you want to measure the center of something, like a tree, but you can't physically occupy the center of the tree with your pole. So you can go into your method and choose the horizontal tilt offset. So what we want to do here is we want to add an offset value in here um, to offset into the tree. So in this case here, it's 0.2 meters to offset into the tree. And that's the distance. And next we have to define a direction. Now, because these receivers know which way they're facing and which way they're tilting, when I tilt it, you can see there, it knows which direction to offset it. You can see where it's going to offset that point. It's also red because it needs to be tilted far enough for it to determine a good direction. So it'll go yellow when it's ready to go. It'll go red if you haven't tilted far enough. So there we go. You can see in that point there, that's where the position is going to be measured. So I can simply just measure and store that. And that's given me a position at the elevation of my pole tip in the center of the tree. If you don't have a receiver that but still want to do something like this horizontal tilt offset, there's a couple of other options. In Trimble Access, there are a lot of COGO functions that can be really useful. So let me jump you to where we go to this. We have a COGO function called compute point. And if we do this from a baseline, we can define the baseline. So you can see in this video, I've laid a tape measure out along the ground, and that's in the direction that I want to offset the point. So what I'm going to do here is I'm going to code this thing as a communications pedestal, and I'm going to just measure my baseline. So instead of typing in a start point, I'm going to tap the little arrow in the corner of the field and click fast fix. And that's just going to take a single epoch at the position I am and store that as that start point as a temporary point. Then I'm going to go to the end point of this line and again, do another fast fix. Store that point, and you can see now in the map, there is a graphical representation of that baseline. And I can key in my offset that I want to do it and the direction that I want to do it from, either out from the start, in from the end, and a vertical offset. So now I can create that point in the center of an object, even though I didn't have a tilted receiver. So there's a lot of really powerful. This is just one of them, but a lot of really powerful COGO functions that you can use in Trimble Access that help you sort of do your job without having to maybe use the the last thing here I wanted to cover was Trimble Connect for data sync. So what I've got here is I've got Trimble Connect open. This is how I would get my files across from my Office software or my Office desktop onto my controller. Now it's really just as simple as drag and drop. So I'm going to open Trimble Connect and create a project. Here's my project. All I need to do now is take the files from my desktop and drag and drop them into Trimble Connect. So here I'm uploading my files and we've uploaded them to Connect. And now in Trimble Access, I'm going to find that project and download it. I think here we get a warning to say that this project wasn't created in Trimble Access. Do you want to continue? I'll select the files I want. There we go. But we want to continue. And we got these files to download. Tap download. They all come through. Now we're in the project. I'm going to create a new job. And under Layer Manager, here are all those files that I just downloaded. So I can accept that. You can see they're all going to turn on in the map. And it's really just as simple as a drag and drop to get those points from the office to the field. So I think we've just reached the half an hour point, and that's pretty good timing because that was the last of my slide. Now I think we'll take some questions. So I've got one question here about the New Zealand cost of total station instruments. Now, unfortunately, I'm in the product development side of things. I work on the software. You're going to have to talk to the local dealership, or it maybe reach out to the geospatial world folks to talk about how much the cost is going to be. Can I explain about the intersection point? So I'm assuming, let me jump back, that we're going to talk, we're talking about this multi-tilt point. So yeah, so because the instrument knows, it doesn't know which direction it's facing. It knows how much it's tilted. We can determine from that we can determine a radius to draw around the center of the receiver because we know the length of the pole. We know how much it's tilted. We can determine the radius. So we draw that radius, and then we draw 3 of those, as you can see here. And again, it depends on your intersection. So if you've done, if you haven't really, you really want to form a big triangle if you can with your tilted points, that'll give you the best geometry. And what we have here is the horizontal precision and vertical precision of those, the intersection points. So next question, can compute point replicate with a total station prism rod? So I think maybe we're talking here to the compute baseline, this one here. Yes, you can. So here it says fast fix. I think under the total station, it will just say measure, and you can tap measure and it will create a point there. So you can, yes, use that same functionality with a total station. Next question. What's the margin of error using this technology? So when we're using a GNSS receiver, you can see up here at the top, we have, that's a tilted receiver. Let's jump to something like this. So if we're using the tilted functionality, this is to 1 standard deviation. So we do have error. Error does get introduced the more you tilt it, and that'll get applied to that value you're seeing there. If you want to change what's displayed, you can go into the job properties of Trimble Access and change the display precisions to a 99% 99% confidence interval, or a 99, or 1 sigma, or whatever you want. Next one. How error due to tilt can be removed? So I'm assuming you're meaning when I tilt a measure, tilt to do a tilted measurement, how can I remove that error? Now, just like with any measurement, there's always going to be some error. The best way to do that would be to take multiple shots at multiple times and average that. Again, I would always say, because tilting it will always introduce some error, if it's a very, very important shot, like a control shot, actually within Trimble Access, if you're taking an observed control shot, we will turn off the tilt, because we say that it's more important to stay on. This is for an example for a measurement with 180 seconds or 180 epochs. We would recommend that you measure that without the tilt to just be to get the best possible measurement you can. That looks like all the questions. If anyone else has more questions, please feel free to write them in. Or if anyone wants me to, we've still got 10 minutes. So if anyone wants me to show or demonstrate some of the software live, I can do that. If anyone has any suggestions of what they'd like to see. So what I might do here is, just while we're waiting for questions, I will open up Trimble Access Live on my computer. and show you around the software. So here I've got Trimble Access running, and I've got that's what I showed before, the CAD toolbar um, to help do your coding. And I might quickly demo some of the other Kogo functions. So there are a lot of Kogo functions within Trimble Access. Some of my favorite ones are the area calculations, which are really good for cadastral applications. So here I'm just going to quickly key in a few points uh, so we can get an area. So here, for example, I've got 4 points, and we've already got a point name with that. And what I want to do is I want to show you how I might subdivide that area. So first I could actually create a polyline around these. So there we go. Now we've got a polyline. So I could click that polyline and I could go to my area calculations. And this takes me to this form. So I could call this lot 54. And I could choose different ways to subdivide this. So I could choose parallel, which lets me choose a line and then key in the area. So I might say, I need this area to be 30 square meters. Or I might say this area needs to be 100 square meters. And then I can calculate these points here for stakeout in the field. So there's a lot of applications here you could use this. I could swap the area because I want to do it I want this area. I could go back and instead of using a parallel line, I could use a hinge point. So I could say, actually, I want to go from this point and I want to hinge this line out with an area of 100 square meters. And then if I wanted this area to be 100 square meters, change that there. There's a lot of different options here, and there's a whole lot of really good applications. So whether it's cadastral or engineering, there's something in the software for everyone. I think we're reaching the end of the webinar, and as there's no more questions, I'd say thank you for attending. And if you do have any more questions, feel free to email me at luke_johnson@trimble.com. Thank you very much.